Alright, it's time for another math easy solution. To discuss further into calculus with parametric curves and look further into tangent series. You go over example 2 and part 1 of this example just because it's a bit long, so it's separated into two parts. And let's continue further. It's the example states, find a tangent to the cycloid x equals r times theta minus sine theta, and y is equal to r times 1 minus cosine theta at the point where theta equals to pi over 3. So if you haven't already, make sure to watch my earlier videos on the cycloid. I put the video links below, and in this video I'll go over part A, and then the second part I'll go over part B in the next video, so stay tuned for that. So again, make sure to watch the cycloid video, and basically if you recall, and I'll put the links below, recall for a cycloid, what we end up having is, again, we want the tangent to the cycloid at this point. What this means is if you were to graph this is an x, let's say y coordinate system, a cycloid shape looks something like this, where it just goes on and on. You can go backwards as well. And the cycloid is formed by basically rotating a circle and then tracing the point on the end of the circle. For example, in this case, let's say we have the radius, the full one is like this. I'm going to draw a circle like this across. Yeah, so it's how it looks like. So here's the point we are tracing is at this point, and if we draw across, the theta parameter is over here. That's our theta. So in this case, this is roughly equal to, well, pi over 3. Or pi over 3 right here, and this is in radians. That's about, yeah, that's 60 degrees in angle, if you're looking at degrees. And basically what we want to know is the tangent line right across here. Yeah, right across on this line, across it here. Yeah, I'll draw that better. Just so then we want to know this tangent line across at this very point. And this tangent line has this equation of a line y equals mx plus b, where m is the slope. And basically what we want to solve is this tangent line. This is the thing we want to solve. So y equals mx plus b. So recall, yeah, whoops, I don't know what happened there. But anyways, recall the equation of a line. And I have a video on this in my earlier video, you could check it out. Equation of a line is just our y equals mx plus b. So we have y equals to mx plus b. So b is that y-intercept, m is the slope. And first let's determine what m is, and this is at this point at theta equals to pi over 3. So m equals to slope equals to, well, the derivative dy over dx. And now if you recall from our earlier video on tangents for parametric curves, the derivative is, you could also write it in terms of the parameter, so dy over d theta. In this case, our parameter is theta, and then we have dx over d theta. So this is the derivative, yeah, dy over dx is in terms of both of these two ratios, the dy over d theta and dx over d theta, and we can solve these because, well, we know these equations. So d over d theta of the y is over here, r 1 minus cosine theta, and then the x is r theta minus sine theta. So we have like this is going to be r, put it like this, 1 minus cosine theta. And then on the bottom one we have d over d theta of the x one, which is going to be r, and then theta minus sine theta, like that. And now we could just do just derivatives using these trigonometric functions. So this r is just a constant, that's just the radius actually. Then 1 minus cosine theta, and the 1 is just derivative of 1 is just 0. Now we have negative cosine theta. The derivative of cosine theta, recall, is just negative sine. So that means we have plus sine theta over the bottom one here. Now we have r, again it's constant, theta, the derivative of theta is 1. So we have 1 minus, and then derivative of sine theta is just cosine theta. So we just have sine theta over 1 minus sine theta. This is positive, we just remove that. So that is what our dy over dx is equal to. Dy over dx, put an arrow like that. And now at at theta is equal to pi over 3 is what we're asked to find. And to find this slope is, it's basically now what we have is dy over dx is equal to sine pi over 3 over 1 minus cosine pi over 3. And now to solve these, recall the exact trig ratios, and I'll put the link below in the video description. And a quick way to, I'll just put a recall right here, and a quick way to memorize this is just draw a equilateral triangle where this is 60 degrees, which is just pi over 3 radians. And again, and this is every single one is 60 degrees across. This is also pi over 3. And then let's say every single side is 2. So then this one's going to be 1, this side's going to be 1, and then this one here, using Pythagoras, you can solve this. This is just square root 3. And you could do that, just go 2 squared minus 1 squared, that just becomes 4 minus 1, and all squared, you get 3. So this is a quick way to memorize. You can learn more about this, put the exact trig ratios video in the video description below. Check that out, it's pretty cool. So what this means is if we wanted to get the sine of this is pi over 3 radians. Sine of pi over 3 is opposite over hypotenuse, which equals to square root 3 over 2. And then the cosine pi over 3 is this adjacent over hypotenuse, which is going to be, this one's going to be, this is just 1 over 2, like that. And also you could use this for getting the angle for 30 degrees. That's just over here, which is, well, pi over 6, just divide it by 2. Across, and then you could do ratios for that for other exact trig ratios. Anyway, so now that we have this, we could throw these inside, and then what we get, I'll just put it down here, we get dy over dx is equal to sine pi over 3, which equals to square root 3 over 2, divided by 1 minus, and then cosine pi over 3, which is going to be cosine, so it's 1 minus cosine pi over 3 is just 1 over 2. 1 minus 1 over 2, that's just 1 minus a half. That just becomes, well, this is the square root 3 over 2, and then divided by a half. You bring the 2 up top, they just cancel, or this is just 1/2 divided by 1/2, those cancel. We just get this is equal to square root 3, and this is our m as well. That's just our slope. So now what we have, is y equals to square root 3x plus b. Now we want to solve for b, and this is all at theta equals to pi over 3. So to solve that, we get x, we could just plug this inside. So recall the equation. X is r theta sine minus sine theta, and then the y is again r 1 minus cosine theta. So we could just plug in our pi over 3, so we get r, and then theta minus sine theta, so that's pi over 3 minus sine theta, which is again, that's a sine pi over 3, which equals to r pi over 3 minus, and then the sine theta over, sine pi over 3, that's just square root 3 over 2. Square root 3 over 2, like that. And there is our x coordinate at this point. And then we have over here y is equal to, well, r 1 minus cosine pi over 3, which equals to r 1 minus, well, 1 over 2. And that's just 1/2, so that just becomes 1 minus 1/2 is just 1/2, r over 2. So what this means now, we could rearrange this, so we get over here, we could rearrange this so we get b is equal to y minus square root 3 times x, where y is equal to r over 2, and then subtract this all by square root 3, and then this is the x, we could take out the r, so now we have pi over 3 minus square root 3 over 2, like that. And now we could just play around and simplify it further. This equals 2, and we could take the r out, so we get r 1 over 2 minus, and then multiply the square root 3 inside, so we get the square root 3 over, and I'll move the pi in front, so pi square root 3 over 3, like that. And then we now this minus and here becomes positive, so plus, and then the square root 3 multiplies by each other, that's just 3 over 2 like that, because yeah, square root 3 times square root 3, the square roots cancel. And here what I'm going to do is I'm just going to simplify this further by multiplying this by square root 3 over 3, so that this again becomes 3, and this cancels with the bottom one there. And then what we're left with, yeah, these disappear, and we're just left with square root 3 at the bottom, just to make it look a bit neater. And now we have 1 over 2 plus 3 over 2. That's just, well, 4 over 2, which is just 2. So this equals to r 2 minus, finally, these square root 3's cancel, become 3, 3's cancel, we have this over there. We get pi over square root 3, like that, and this is our b. So this means our equation is y equals to m, which is square root 3x, and then plus b, which is r 2 minus pi over square root 3. And it's slightly different than my calculus book, just because I like doing it this way instead of the way they did it. So this is a better way in my opinion. Yeah, and here what I've done is I've graphed it using that amazing decimals calculator, and you could just go and see this here just to show you. And yeah, I'll put the link is in the notes here. You could download and play around with it. So basically here what I've done is I drew the parametric equations, and here's for r is equal to 1. You could move the r different values and this changes, but I also graphed the equation over here. The y equals square root 3. This is the tangent line, and then plus r, and then this is plus r times 2 minus pi over square root 3. And as you can see, it's tangent to this point all the way across here, and this is pretty cool actually. So the blue is a tangent line, and there's our parametric equation, and I have this from, and instead of I couldn't put theta, so I just put t instead, just for reference there. And then this is from negative 6 pi to 6 pi, and we have, because it's 6 pi, a full rotation is 2 pi, so we have 3 of them, so 3 full rotations as you rotate that ball around. Anyways, that's over there, and you could see it. And again, I just want to make a note right here. This is t is equivalent to our theta. We just can't use that in that calculator for some reason. And at this very point is our, and then our graph right there. If we were to graph this, let's see how the circle would look like. And again, this is at somewhere like that. This is at pi over 3 is our theta, which is pretty cool. Yeah, like that. And there is our graph, and I'll put a y. This is our x. And there's our y equals mx plus b, and there's our cycloid curve for r equals 1. It's pretty cool. Anyways, all for today if you learned. And yeah, like always, you can download these exact notes in a link below, and I'll do part 2 or part B in the next video, so stay tuned for that. Anyways, thanks for watching, and yeah, stay tuned for another math easy solution.